Hello, this video is about how matter tries to achieve stability and mainly through ionic bonding. All right, now this is chemical stability at like room temperature area level, like around like now in around the earth at around room temperature. Things get changed when you make extremes, like I'm gonna make it really hot. This really wouldn't apply because the matter would behave differently. Now, matter loves stability. It kind of is like a governing law. It'll do things to get stability, like it'll react with things naturally in the air to sort of lower its state of energy. If you make things hot, they tend to cool off. It's like a law of thermodynamics. And matter's chemical stability, now we're not talking about the nucleus, we're talking about its chemical stability, whether it's going to react to make a new substance or not, really has to deal with the valence electrons and how many it has, the number it has on its outer shell.
Mr. Lee, could you please go down to the nurse's office?
The law of the land is that matter tends to want a complete outer shell. It either has a complete outer shell if it has 2 in the first energy level, and these are elements like beryllium and less, or it's got 8, and that's basically every other element above beryllium. Some examples of this are the noble gases like helium, argon, neon. Those are chemically stable. They don't react. They have a full octet. And now, when matter does not have a full octet, like, I'm hungry, it's going to do something with its valence electrons. It's going to gain or lose them, give some to another element to get its 8, or it's going to gain it from another element to get its 8, or it's going to share. Now this is going to mainly talk about the type when it gains or loses. What are the after effects of ionic bonding? All right. Now, if you can look at a periodic table and just remember a few basic things, you can figure out which ones will gain or lose. The metals tend to lose, okay? Metals are losers, everybody knows that. Non-metals, and that's these elements above the stair-step line, they tend to gain. They're gainers. They're out there gaining things all the time. Now there's a couple small exceptions. Hydrogen is a non-metal. Some of the time, depending on the temperature, it's going to tend to gain, or like if you were to bond it with a metal, it would gain electrons. The true way to know these is to look at their electronegativity values and compare them, and that's how you would know what the things are going to do. Now, when metals lose, they become positive because they're losers and they lose all their negative energy with the electrons and get their full octet. So, magnesium is in group 2, so it has 2 valence electrons. So it would tend to lose those 2 valence electrons to get its octet. When it loses its valence electrons, it's going to become a cation. And a cation is a positive ion, cat ion, and it'd be Mg+2. Chlorine would gain, and it has 7, it would gain 1 and become an anion. And that's it. Just beat the music.